hopefully we are good. Okay, so this is CET 466, last class meeting. I had intended to get a little bit further myself with how the whole group project is supposed to go. Unfortunately, this week has been a complete disaster for me. I had to be in New York on 2 days and Boston on another day. So I just haven't had time. But what I'll do is I want to take us through from a top-down perspective what it looks like, and from a bottom-up or a component-by-component perspective what it looks like. Morning, Connor. So let's have a look. Well, let's start with this. Right, so we've got the zyBooks. That's it. I believe the last date is the 16th rather than the 14th, but other than that, I think I have 11 of the 12 students scheduled, so I need to get that one other person scheduled. I think only the highlighted things, the project, the oral, and the optional game part are the only outstanding things, right, in terms of assessment. And I forgot whether I put it in or not, but I think I have 11 out of 12 students booked. We haven't had a meeting since I made that, that's what I forgot to put in, since I made that exam available. So let me just walk through that as a first step. Oh, come on, where are you, Authenticator? There we go. You're going to ask me something? There, now you're asking me something. I should have clicked the box. Oh well. Don't know why it can't remember. Keep 14 days rather than whatever it is, 24 hours.
Yeah, that doesn't work outside of this campus too. On my new job, we have that same thing going on, and even if you click stay signed in.
Oh really?
Yeah.
Yeah. Most of my career I've written software, and it bugs me beyond belief when I see bad software. My 2 most recent bad software experiences are AT&T's website is atrocious. It bangs and clatters and flashes and does all this sort of stuff when you're just trying to log in. And the other one that I found out recently is Kineticare's. They have a messaging system, and there's other things wrong with it, but the messaging system has messages, and one of the columns that you can sort by is date. But it puts the date in month word, so December, space, number, comma, date, year, right? And if you sort by that column, it sorts alphabetically. Which is just, who in their right mind? Sorry, I don't get me started on software. So I did want to see So let's see if we can view that in full screen, maybe. Might be better. Right, so this is the, let's make it a bit bigger. I don't think I want to see that. No. Get rid of the thumbnails. Maybe I can't get rid of the thumbnails. There we go, there we go. Right, you can use whatever resources you like, but we're talking, so you can't take too long to answer. Mostly I'm about process, although this exam has more definitional stuff as well. So we'll see about that. Probably won't need anything to write on, although sometimes that, for some of these questions, the answers might be easier if you can just upload an image or something, or at least display your screen. And where are we? Start at the top there. So the exam, you've basically got to answer 7 of these, I think there's 18 questions. You have to answer question 1, and the other 6 are up for grabs. Question 1 is just about pieces of VHDL, and you can choose 5 of them, and I'll choose the other 5. And some of these we've definitely talked about, others maybe not so much. Generate, procedure, I don't think we've talked about much. Most of the others, maybe range, most of the others we haven't really talked about. So I suggest you read up on all of them, but particularly the ones we haven't. And I think we sort of had question 2 previously, but it's good to remember what the static logic values are. Question 3 is about how to do simple Boolean operations in VHDL and how they combine. Question 4 is about lab 6, to see that you got something out of lab 6 with Richard's lab, right? That you understand what was happening there and what you had to do about it. Question 5 is about the group project. I want to hear specifically what you got out of the group project. Did you have a question, Fahim?
Yeah, I want to ask about question 5. What do we have to explain? Like, can you explain a little bit more what we do different and what work? Because the project is built to a component, and each student to one component. So how we should explain and what's the difference?
Right, so I want you to do 2 things. I want you to be able to explain the whole project and to explain your part of it. What piece did you get involved with? Right, and some people had specific components assigned, other people didn't, but had more of a communication role. Right, so there's lots of room there for explanation. But so this question, one of the things when you're learning stuff is you want to learn facts sometimes, right? So the question 1 is about facts. If, generate, process, whatever the fact is. But if you're actually learning stuff, sometimes it's better to step back from the coalface and reflect on what you're learning. And that question 5 is more of what I would call a reflection question. Okay? And it shows me, your answer to it shows me how you think about your learning. Right? And that's useful for me too. Does that answer the question,
Yeah.
Fabian? Yeah? Okay. Here's a, I think we went over this last lecture, so it should be reasonably straightforward. I talked about question 7 last lecture as well, synthesizing a latch. And there's some specific things about signal assignment. One of the things we've done with Quartus is we've taken a component and we've put a test bench around it. And here's a component, so the first part of this, and it should be pretty clear what this component is doing. Maybe not necessarily the details, but the name of the entity should be a pretty big giveaway, right? But then how do you test what this is? Remember, I've pushed this plan, do, review, and the review part is the test. One part of the test bench is to exercise the device. The other part is to verify the device. Does the device do what it's supposed to do? And that's where you check, use an assert statement, and you have a report if there's an error. We talked about the Klein-Mitrosky algorithm as an alternative to K-maps for logic minimization. Question 11 is again about plan, do, review, and again this is more of a reflection question. Question 12, we have a device that is doing something. It's not quite sure what it's doing. It's doing something. And there's something wrong with the process block. And the question's asking, first of all, explain what's wrong and then fix it. Question 13 is more about just can you read VHDL and figure out what the device is doing. Again, this one doesn't have a nicely named entity or architecture statement, so it's a bit less clear. What's the difference between a normal machine and a Mealy machine? Right, one of them only uses state, the other one uses input and state. And then remember one of the first things I think I told you about VHDL is that every statement happens at once, except when we're inside a process statement. When we're inside a process statement, things happen sequentially. So question 15 is about what sort of keywords would you use inside a process statement. And 16 is similar to question 5, but not as reflective, right? It's just about explaining the whole CPU. Question 17 is just a quick, what's the difference between the hardware between a PAL, a programmed array logic device, or an FPGA. And then the last one is basically asking how a lookup table works inside the FPGAs we've been using. Oh, there is a 19. There we go. Then 19 is another, can you read this VHDL? And what does it do? Right, we've got a a D flip-flop happening, but then what's this generate statement doing? And what is the overall device do? Any questions about the following? No? Okay. Let's go back to the slides. So, yep.
So if we answer question 1, are you going to pick the rest, or we have to pick them?
So I'm going to do the same sort of thing, right? You have to answer question 1. There's 6 other questions you've got to answer. You can choose 3. I'll choose 3.
So you choose 3 and you choose 3?
Yes. Okay. So part of the reason I do it that way is I think it gives you a chance to show me what you know, right? And it gives me a chance to knock holes in it.
So for question 1, you have to answer everything? Or it says choose 5, you choose 5.
Right, so there's,
So
I think it says, let's go back to question 1. Explain 10 of the VHDL keywords in the table below. You choose 5, I choose 5. Okay, so I think there are...
So we choose 5, you choose 5, but then we also choose 3 and we choose 3.
That's correct. What the other questions? Okay. Okay. Any other?
What you expected from us to explain, like if there is not that much to explain about it, it's just if in this like if statement, what you have to like explain or
So-
like a short answer.
So the usual thing when I ask explain is, so let's take if, right? One thing that is, first of all, explain what it is, right? Everybody knows if they've done any programming what an if then else statement is, right? So you say it's a way to conditionally execute something, right? But then you've got to also add that because it's a sequential keyword, that it has to be, it can only be used inside a process statement. Right? Then you should, anytime I give an explain question, you should have an example, right? So you should be able to give a simple example of what the thing does, or how it's used in practice. Okay? Does that answer the question? Yeah? Okay. So let's go back here. So the CPU, as I said, I had my week blown out from underneath me, so I haven't had a chance to do as much as I'd like. But I got a fair way. And about the only thing I didn't finish, I believe, is the CPU and then making sure everything connects together. So what I thought we should do is look both graphically and also at the code, first of all starting at the top and then coming down, and then looking at the individual components. So let's do a drawing. And I think I've done something like this before, right? But the main 3 components that we had to look at were the ROM, the CPU, and the RAM. And we had connectivity here. We also, because this is a synchronous device, we have a clock. Okay. But there are a few other pieces here as well. One of the things is we wanted to be able to see what's happening on the device. Right? So we wanted to take the output from the program counter and display that on the 7-segment display. The other thing we wanted to do, and I think the place we should do it is here, we wanted to take, say, memory location 0 and display that on the LEDs. So we could look at least at the lower order 4 bits of memory location 0. One of the things we wanted to be able to do is we wanted to be able to manually switch the clock, and the other thing we wanted to be able to do is to reset. So we wanted to use two of the switches. Okay, so we have a manual clock, we have a manual reset. So they're the things that we wanted to be able to do. Now, can anybody tell me what is wrong with this? Or what's different between this and this or this? My app has expired. I haven't pushed a version of it. So let's just go around the room. Mohammed, what's different between this and this or this or your laptop?
Only handles 16 bits, I think.
Yeah, that's okay, yeah. That wasn't the answer I was looking for, but that's a good answer. Yeah, Eric?
The instruction set comes from the ROM, right? Peripherals?
Okay, again, not quite what I was after, but yeah, there's like, this thing has a keyboard, it's got a tablet, it's got a screen. Right, there's the only peripherals we have. In fact, one of the things I want to try and do with this, if I keep this project going next time I teach this course, is I think the next time we'll try and finish this completely. But then the time after that, I want to add a keyboard driver and the VGA output to it, so you can maybe start thinking about it like a real computer. Again, not the answer, good answer, but not the answer. Fahim.
Is the way the card has connector for the reset as goes in the 7-segment and the LED, like the way how is the component in the unit itself connected?
Okay. Yeah, is also a bit different from what a standard computer. Okay. Michael G. So the question is, I've just drawn the architecture for the CPU, right? And we've had several answers about what's different between this and one of these.
Yeah, it doesn't have buses on it.
Okay, yeah, that's a good one, right? So most of these computers have a one or more, usually more bus systems. We don't have that in the network. Matt, again, not the answer I was looking for, but a good answer. Matt, what are you? No? Right, how about you? Microwave?
So the laptop and these desktops are complete. This picture is incomplete.
Okay. Yeah, there's lots missing. Okay, another good answer. Michael P. Did you hear the? Did you? Okay, so the question is, I've just drawn up the top level components that we're gluing together in the CPU, right? And I have, I've got a reset button, I've got a manual clock on the switch, I've got the program memory, I've got the CPU, I've got the RAM. The outputs I want to look at the program counter on the 7-segment display, and I want to look at the 0th memory location on at least the lower 4 bits on the bits. We've had a lot of answers that tell me what's the difference between that architecture and what this computer is actually doing, or what that computer is actually doing. So any thoughts on?
Well, we're dealing, this is all in a different language than what if the computer's running multiple
Well,
interfaces.
actually, yeah, that's a good point. So yeah, that's another good answer, right? I don't believe this computer is described in a single language, right? Whereas what we're trying to do is mostly written in PHP. Still a good answer, but still not the answer I was looking for. So the answer I was looking for, that's okay. This separation, right? The separation between the program memory and the RAM is not the way these computers work, right? Okay, there's probably something like the ROM in probably every component within this computer. But if we're talking about the computer itself, the RAM acts as the storage and where the program comes from, right? There's no separation. This standard architecture is what you would call a von Neumann machine. This split between the program memory and the RAM is what you would call the Harvard architecture. It's a different sort of compute structure. Okay. So one of the things I did, I had a look at several of these. I took what the students had done and either reviewed it and said that's okay, or I made some changes on it. I made some changes to the ROM But first, let's have a quick look. So there's a as you're aware, I'm taking the idea for this project out of a thing called Man to Tetris. And it starts off with the 363 digital logic stuff and eventually gets you to writing the Tetris game. That's a little bit ambitious for what we wanted to do, and they take some shortcuts in this because it's the right thing to do from a learning perspective. But one of the things they have is they have the assembly language, right? The A instructions and the C instructions. And they have a compiler for it. I suppose it's more like an assembler, but this is more like an assembly language that is written in Java. And you can load up the program on this side and it'll spit out the 16-bit words. Remember whether it's an A instruction or a C instruction. Right? They're the C instructions, and the C instructions have 3 ones in the high order bits. Right, so if you have an at, that's an immediate load or a constant. That's an A instruction. So at 2 becomes 3 zeros, well, 1 0, and then the binary number 2. And D equals A means you're going to take that number. That at 2 means that the number 2 is loaded into the D register. Or sorry, into the A register. And then the next instruction says take the A register and put it into the D register. And then the next instruction is load the number 3 into the A register. And then it says add the D register to the A register and store the result in the D register. And then it says load 0 into the A register and then set the memory location pointed to by the A register, which is memory location 0, set that memory location to be the value of the D register. So what this example is doing is it's loading 2, it's loading 3, it's adding them together, and it's storing the result, which should be 5, into memory location 0. Okay? So let's just go back, maybe. So let's have a look at, I don't remember if lots of updates from students. Very good. Okay. So the entity that I used to make that diagram you just had, I called pull it all together, right? And here's the I/O. Remember, we've got to connect to the actual physical 7-segment displays and the 4 LEDs. So there's the LEDs. Remember, our 7-segment display has one output for the 7 segments, and then another output to select which of the 4 digits we're displaying. And then there's the reset line, there's the clock line. I decided we also needed the 50 megahertz clock, right? Because I wanted to manually, let's change it back. So I wanted to manually clock the board. And because I wanted to manually clock the board, I wanted to put in here the debouncer. Similarly, for the reset, I wanted to put in a debouncer. And that debouncer won't work on the manual clock. Right? It's got to work off the board clock. So I needed to put in a board clock, at least to get those to work. Okay, so that's why the board clock. So that's the entity. And then the architecture. One of the first things you've got to do with a high-level architecture is define all the pieces, all the components. Right. So the first thing I defined is the debounce switch, and then I've got the RAM, and then I've got the program memory, and then I have the CPU, and I have the 7-segment display. One thing I'm missing, I think, is a reference to the LEDs, but I may not need that, so we'll have to think about that. Notice that I've tailored the 7-segment display to take in the program count, but I've explicitly named that that's what we do. Maybe that's not such a good thing. Maybe I just wanted to put in some 16-bit number, regardless of whether it's called the program counter or not, but I decided to do that. Then I defined a series of different segments. Right? I have the clock coming in, but I want the debounce clock. I have the reset coming in, but I want the debounce to reset. I want to be able to see the program count. I want to be able to see the current instruction. I want to be able to see the current memory address. I need to be able to see data going to and from the RAM, and I need a read-write flag. And then I can create instances of each of those components that I defined, and I can wire it all up. So here's the clock debouncer. It uses the debounce switch. It takes in the board clock, which is a switch, one of the switches. Sorry, the board clock is the 50 megahertz. The clock is one of the switches, and then it outputs the debounce clock. The reset debouncer takes in the board clock, takes in the reset switch and outputs a debounced reset. The memory is a RAM component, and it takes in a memory address, it takes in write data, it takes in a read-write flag, it takes in a clock, and it displays the data that you want. The ROM is we call program memory. Takes in the debounce clock, the program counter, it outputs the instruction. The processor is the CPU, takes in the clock, the instruction, the read data, the debounce reset, and outputs the write data and a memory address. And the 7-segment display takes the program counter, the board clock, and outputs the digit and then the digit select line. And I think that's mostly all we need. I think we're missing something on the CPU though. Probably because, yeah, there we go, right? The CPU is outputting the program counter and the read-write flag as well. Okay, so that's my attempt at VHDLing that diagram based on the components that you put together. And even though I've only drawn one wire here and here, there's actually two. There's an address and a data line. So that's that. Any questions about the top level entity?
Does it work?
Sorry?
Did it end up working?
That was I haven't finished the CPU, right? So I was hoping maybe we could spend some time doing that today, and we'll see how far we get. But I wanted to explain what is there first, and then we'll talk about what's next. Okay, that's the top level entity. And then here we should be able to see let's have a look at the program memory. Alright, so the program memory takes in the clock, takes in an address, and spits out the instruction. I decided that I wanted to make this program memory as small as possible and not give any particular errors. So what I did is I took that assembler that the NAND to Tetris guys have put together and I wrote a little program. And I meant to check to see I don't know whether it's here. There it is. Right, so here's the program I wrote. beautiful, isn't it?
It is.
What does it do?
Absolutely nothing.
Say it again. No, it does do something. What does it do?
Is this a assembly?
This is the assembly language that the Manta Tetris is. Well, Emily, you know what it does. What does it do? Anybody? Nobody. Okay, let's walk through it. Okay, so remember at 0 just loads the value 0 into the A register. That's the A instruction, right? The top level bit is 0, so that loads the value 0, or rather 15 bits of zeros into the A register. The next line, line 2, is a C instruction. It takes whatever's in the A register and puts it into the D register. Line 3 takes the value 1 and loads it into the A register. Line 4 then says add what's in the A register to the D register and put the result into the D register. So we add 1 to 0 and hopefully we get a 1. Let me just save this. Does we have a markdown? You do not have a markdown. Okay, so let me just write that out, right? So here we go, load 0 into the A register. Load the A register into the D register.
Yeah, I'm confused. So does this code actually run?
Yeah, that's the point.
Because in my microcontroller class, in assembly they have actual like instruction, I guess such. Like for example, like move dot W.
Right. So this is a move.
The D is a move.
The D equals A is a move. The whole instruction is D equals A. It's not D separate from equals separate from A. The instruction is D.
Because to me that just looks like an assignment. Like it's
Yeah,
assignment
it
A
is.
to D.
And that's what a move instruction is, depending on where the source and the destination is. But that's all a move instruction is. It's an assignment.
How about for line 1? How does the CPU knows to load something? There's no instruction.
That is the instruction. Add is the instruction. Instead of LD, which you might see on another, or a LOAD, right, which you might see on another assembly language. Assembly languages are all completely made up.
Oh, okay. I just thought there was like one
No.
type of assembly language.
They're all different.
In
And
my other
they just decided, the Manta Tetris guys have just decided this is what we're going with as far as a really pared down assembly.
Okay.
Okay? So then this is again load 1 into the A register. And then this is a different instruction. Add the D and A registers. and store the result into D. Load 0 into the A register. Store D into the memory location pointed to by the A register. Right? Okay. What does it do from there? It just repeats, exactly. Right? So those 4 instructions then just repeat. And I decided, because what I decided to make this do, I should have told you to start with, but I thought it would be more entertaining to not. Right? What I decided to make this do is just be a 4-bit counter. Right? So it's counting from 0 to 15 and then back again. So all I did is I just cut and paste those 4 lines of code, so that by the end of it, memory location 0 has 1111 in it. Right? That's all it's doing. And you'll see it goes on, but that only takes a total of 62 instructions. So let me just put in here. Okay, so it just keeps iterating through. And that's all we need to do. Let's have a look, now that we know that. So now it's obvious what it does, isn't it? Right, I just took that assembly language and put it through their assembler. And here are the numbers we need, the A instructions or the C instructions that implement that 4-bit counter. So there's this is back at the ROM, right? And here I've actually defined a generic up the top here for the memory size. Remember, a generic is like a constant, so you can use a word rather than a literal number. And I called that memory size 63. And here's something we haven't done before much, if at all, is we're defining a new type. We're defining a program _T, and it's an array from 0 to memory size -1 of 16 bits to the logic values. And I've also defined a signal, which is the currently accessed memory value. And now I'm using my program T type to define my program. And I'll just take those 62, 63 values from the output of the assembler, and I put them in the appropriate array format for VHDL. Okay, and you should see, okay, it's got the double quotes and the comma, but it should be exactly the same as this code here. And then the process, the thing that actually does all the work, just comes in and says, okay, if the input address changes, then that's the sensitivity list, remember, for the process. The sensitivity list changes, do something, and this is what we want to do. We have a variable inside the process called mod address. And remember, we only have up to 63 memory locations. Our program counter goes up to 16 bits. 63 is what? 6 bits, is that right? 0 to... So I wanted to make sure that we always got a sensible output here. So rather than just using this address as an index into this array, which could give me an error, I decided to make a modulo address which makes sure that this modulo address is always within the range of the memory. Right, so the modulo address is always within the range of your memory. I get the memory value out of my array at that address. And then I connect up that memory value that's set in the process to the output. Everybody okay with that? Okay, let's go back. Right, so I've let's use a better colour. I've talked about the ROM. Let's have a look at the RAM. I've forgotten what I did with the RAM. I'll have a quick look at the RAM and then we might have a break. So here's the RAM. We've got a RAM address. Let me point here so the video gets it. Right, we've got the RAM address. We've got the RAM data in. We've got a flag to say whether we're reading or writing. We've got the clock, and we've got the RAM data out. Notice how big I made this RAM. See the RAM size, generic statement? 2 words. Right? Total of 32 bits, 2 16-bit words. The wonderful program I wrote is only writing to memory location 0 ever. So we could probably get away with only having 1 memory location. But anyway. So again, I've made a type that's an array of student logic vector 15 down to 0. And then I've made a variable of that type, and I've initialized it to all zeros. and then I've got a signal for the data out. And my process, the only thing the process in the process sensitivity list is the clock. And if there's a rising edge of the clock, and if we're writing, that's what read write 0 is, then we take the data in and we store it into the address, the RAM address. Otherwise, we read, again I'm doing a modulo operation here to make sure we don't go outside the bounds of our storage, and we read that back. And then we connect our variable, or our signal, to the output. Any questions about how the RAM is working? Michael, no questions? Okay. Okay, so that's how the RAM works. Let's take a, 10-minute break, and then we'll get back and we'll look at the CPU and the 7-segment display. I think we might have had a look at the 7-segment display before, but we'll have a look at the other components. Let's go with that. Background investigation. Sorry. So one of the things that blew up with me today was paperwork like but paperwork like that is not pretty.
So Sunday we meet at 2 o'clock. Basically, want to discuss our rules. Which part you got? You have pizza yesterday? You should. That was my first meal of the day. I ate pizza. It's good.
You took the rest of you.
I think somebody ate it. Fugitive, like just to fly around, like singles, because I was watching some clips yesterday on phones. It's funny stuff. Like nowadays they have like the drones that you can use the goggles with, and then you can see like what's happening. It's called like it's a FPV, person view drones. It's just crazy. But they cost a fortune.
That's a crazy one.
write code to like protect the cloud. Like I'm on a cybersecurity team, so I write a whole bunch of code to protect like the server cloud of all the like insurance portals, insurance
So you constantly push into the cloud. So it's not.
And I have two other people on the team that help the other team push code and stuff like that. But specifically, like, I do all the automation to automate the other two people's analysis code so that I can just, yeah. And then so I can just literally plug in the command, hit enter, and then run all of the simulations for just
So
so I can get data quickly.
try to push it back. Often you say,
Don't do that. You should look at
Okay. So let's get back to it. So far we've looked at the ROM and the RAM. I think I want to have a look at the 7-segment display next. So let's see if we can do that. I'll just close up these other versions. So let's have a look at the 7-segment display. Pull that out as a separate window. As we saw earlier in the component statement, we've got the program counter coming in, we've got the clock coming in, and we've got the particular digit, and then the value of the digit, and then which digit. I just remembered that I wanted to check what did I do there? I did, okay. Let me just go grab a board. So the nice thing about the 7-segment display stuff is that it shows quite a bit of what you need to do. Okay? This sounded very exasperated, that's all. Now, where are we? We want to get that one there. And I don't think it matters which goes which there. So let's put, you've got to do both on this side. That one there. And I think I'll put it out here. We want the JTAG input. And then we need that power. USB. So there's the. So what I did is, there was a separate. I think Michael had started this up. There was a separate 7-segment display project, and I had a look at. I wanted to debug what I was doing in the 7-segment display and separate from the CPU. So I think I put that together here. Here we go. Maybe? I really should get myself a faster computer. Let's just have a look at what this is doing. Okay, so we've got a button. We've got a clock, we've got the as inputs, and we've got a digit and a select digit as outputs. We have a component of the 7-segment display, and we have a component of the debounce switch. And then we have a count, a number, a debounce button, and we have a process. And then we've got the instantiations of the display, and we've got the instantiation of the debounce switch, which is debouncing the clock by the looks of things. Right, and the process only does anything if the value of count changes. Right? If the value of count, so there's two processes. So if the value of count changes, we take that value of count. Notice count is an integer, whereas everything else it's a stirred logic or stirred logic vector. So we take the value of count and we convert it into a stirred logic vector value, our number, signal. Right? It's a 15 down to 0 stirred logic vector. The other thing that happens is the process on the debounce switch. So when that debounce switch is on a rising edge, we increment the count. And we're just going to display that in the 7-segment display. So let's have a look at the details of the 7-segment display. Which is where we were before. So one of the things I need to be able to do is I need to clock through each of the 4 digits of the display pretty quickly. Fast enough so that our eyes can't tell the difference. Right? So in order to do that, I need to use a really fast clock, and the only really fast clock I have access to on the board is the 50 megahertz clock. The trouble with that is the rise time of the LEDs and the change in the value I'm displaying can't change fast enough. So if I just fed that 50 megahertz clock straight in, I just get a blur on the LEDs. It wouldn't display correctly. So I have to divide the board clock down a little bit in order for everything to look correct. And so this first process is just taking the board clock, the 50 megahertz, right? And on a rising edge, it's playing with a counter, and if the counter reaches 100,000, then it changes the divided clock value. It negates the divided clock value. And it resets the counter back to the start. So that's just taking 50 megahertz, and what's 100,000? So 50 megahertz goes to 50 kilohertz by 1,000 by 100 again. So it's about 500 hertz, I think. Is that right? Can I do division? Probably not. Let me, so 50 million on 100,000. Yeah, 500 hertz. Okay. So then, the next process is, the sensitivity list on it is that divided clock that we just calculated and the program counter. So if the thing we're trying to display changes or the divided clock changes, then we need to do something. And on the rising edge of the divided clock, we go to the next digit and we select. Remember, on our board, just about all of the signals are active low, right? So in order to select the first digit on my select lines, I have to say 0, 1, 1, 1. In order to select the second one, I have to say 1, 0, 1, 1. Third, I have to set the third digit to 0. Fourth, I have to set the fourth bit, rather, to 0. So that's the first thing that's happening here. So all this is doing is it's just going through the 4 different digits. And this first part is just selecting the appropriate digit. The second half of each line is pulling out the appropriate bits I want to display on that digit. Right? The first top 4 bits, then the next 4 bits, then the next 4, and then finally the lower order 4 bits. We're not quite there yet, because number is just a value, right? Or it's just a standard logic vector 3 down to 0, I think. Yeah, there it is there. Standard logic vector 3 down to 0. So it's just a 4-bit number. But we need to output 7 bits, right, to light up or not light up each segment of the 7-segment display. So that's what this next piece is doing, and this is outside all the processes. It takes the number that we want to display, converts it to an integer, and then says, okay, if we want to display a 0, again, everything is active low. So a 0 means this is also reversed. So this is the A segment, B. Let me do it on the video. So this is the A segment, B segment, C segment, D segment, E segment, F segment. So the only segment that's not lit up when we want to display a 0 is the middle bar, which makes sense. Right? So this just takes the number that we need to display and figures out which. Notice though that it's not complete, right? If anything, if we want to display the number bigger than 4, then it just blanks everything out. That's because I stole this code from this particular code here. I stole from the baseball counter, and we only needed to count up to 4 on the baseball counter. So let's have a look at how that works. like I said, let's close those down. I think we're all compiled. Looks like we are. Let's just open it up a bit. Open the programmer up. And we've got USB Blaster. And we're successful. Right, so you didn't see it. I probably should have showed it to you. But there is the 7-segment display. Right, we start off with 0. We initialized it to 0, so it's showing all zeros. And now if I clock it, and what I want you to try putting your hand up like that and going like that and looking at the 7-segment displays. You should see them flickering. Right? Yeah? Look through your fingers. I should have a video of you all doing this. That would be hilarious. But right, and if I keep, as soon as I hit 5 though, I'm now no longer displaying anything because I haven't coded that part, or it's not on the screen anymore. So let's do something. Let's slow down. Let's slow down the clock division. Right, so instead of dividing by 100,000, what do we want to do? That's 1,000,000, so it's 50 hertz, 5 hertz, half a hertz. Right, and now I'm going to have to recompile, so we might be here a while, but let's do that. So now what I'm doing is I'm going to really slow down that. The only thing I've changed is that number, right? So the clock division number. So what should happen now is you should be able to see each digit as it just gets displayed. I hate it when I use my home password on my work. Just thinking about it.
It's really taking its time.
It gets stuck here forever, and then it usually goes reasonably quickly after that. But for whatever reason, I suspect it's partly because of the video streaming and everything is happening on at the same time. But there we go. I don't know why it gets stuck on 4% so often, for so long. Come on, we can get there. Really? There we go. So now let's see what happens when we program that up. Right, that was what was happening before, but it was happening significantly faster. Probably didn't do it quite soon enough, so let's see if I got a... Right, I incremented it by 1. See if I got it up to 4. No, only 3. I didn't click it enough. Okay, so that's what's happening with the 7-segment display. Okay, let me go back to the other project. Any questions about the 7-segment display?
Yeah, question.
Yeah?
So for the rest of the code, you just want me to like input the next few numbers?
Yeah,
Like
basically if you could just
web?
finish it up, and you should be able to run that that separate quarters project, the one that I've just been running, and see that it actually does count up correctly.
Alright.
So 0 through 9 and then A through F. Okay. And let's open the other one. Why we're there, I don't know. I'm going to do that one. Okay, so that's the 7-segment display. While it's running there, let's go back here. Right, so we've had a look at the 7-segment display. I'm going to go into the CPU, but the CPU is, like I said, unfinished. But let's have a look. Maybe I just did it. So let's just, before we go there, let's go back to our diagram. Okay, so there's the CPU. It's got an instruction coming in, it's got a memory value coming in, it's got a reset line coming in, it's got a memory location or a memory value coming out, it's got a read-write memory location, it's got an address for the memory, and it's got the program count. Okay, so we need this, and this for our RAM. We need this and this for our ROM, right, our program memory. And there's our reset line. I think that's all we need. And then internally we've got muxes, registers, an ALU and a program count. So let's see how that translates here. So one of the things I like doing is using generics to use for names, right? So I often want to initialize stuff to all zeros, so I set that generic. Our CPU entity has a clock, has I is actually an instruction in memory, the reset line, the out memory, the address for the memory, the program counter, and the read-write memory. Right? They're the things we just talked about around the outside of the previous diagram. Then within the architecture we have a component, which is the ALU. We have a register, we have a mux, and we have a program counter. Then I decided to pull out explicitly particularly where there was a circle on this diagram. I decided to make sure I had a signal there that I could use to see. Right, so that's one reason why there are so many signals here. And you can see I use the all zeros to initialize a lot of them. Now one of the things that I got a little confused with on this is when you talk about the way a CPU, a PC CPU works, you always talk about a fetch execute cycle. Right? You've got to go away and get the instruction. Once you've got the instruction, then you can execute it. So that's why I have these pieces down here to think about doing that. Just like the assembly language that we showed earlier is a really cut down, simplified version of what a normal assembly language would be. The NAND to Tetris guys also use their version of HDL. Right? HDL just means hardware description language. So their version of HDL is a cut down version. It's not VHDL like we're using here. And I think because they use that cut down version, I don't think they have to think about fetch execute. I think they can just wire everything up, and because of the way they've done the simulator for their HDL, I think it'll all just work. I don't think we have that luxury here. Anyway, so here's a list of the instantiated components. We have an A register, a D register, right? An AMUX, an ALU mux. Let's just go back. Right, so we have an A register, a D register, an A mux. So which is the A mux? I think it's this one. This is the A mux, and then the ALU mux. The program counter, and of course the full ALU. Right? So that seems that lines 97 through 103 seem to capture, 104, seem to capture all the components. I'm not going to go through and figure out whether they're all connected up correctly, but I'm assuming they are. And then here's a process on the clock, on the rising edge of the clock. We want to see if we've got the whether we're in fetch or execute. and I haven't changed how fetch works, so this isn't actually going to work properly, but anyway. Right, we pull out the current instruction and we store that. And then here we wire up the output of the ALU to the out memory, the write memory flag to the output, and the output of the PC, the program counter to the PC output. Like I said, I think there's a few things missing, particularly here, and that's the piece that I didn't get completed. So let's go and have a look at some of the other pieces, the CPU register. So let's have a look at the CPU register. Where'd it go? Oh, it's inside the CPU, so we need to do that one. Okay, so here's our register. It's a generic register. It's both the A and the D register do this. It's got a clock input, it's got a reset input, and it has a value input, it's got a value output. We have a register value, which is where we store the value of the current value of the register. It's then got a process, which depends on the clock and the reset line. If the reset line is 1, so it's an asynchronous reset, right? There's no dependence on the clock. If the reset is 1, then we set the value back to 0. Otherwise, we check the rising edge of the clock, and if the rising edge of the clock is true, we take the input and we store that value in the register. And then outside of our process, we connect up our signal to the output. That's pretty much all we need to do. Any questions about the CPU register? Right, so that is those two components, exactly the same component. Let's have a look at the mux. Right, it's a multiplexer. We've got two inputs, input 0 and input 1. We've got a clock, we've got a select line, and we've got the output. And if the clock changes on the rising edge of the clock, and we have select 0, then we use input 0, otherwise we have input 1. And here, there's no real need to have a temporary variable, if you like, a temporary signal that we need to make this change to. So just doing it this way should be okay. One thing I tend to get into the habit of doing, though, is I do tend to have a signal that gets changed within the clock, within the process rather, and then I wire up that signal to the output. Okay, so that's the two muxes. Let's have a look at the program counter. Okay. Right, again, I've got the all zeros, we've got a clock input, we've got the register A input, we've got a reset input, we've got a load from A input, and we've got the current address as a signal. When the process happens, sorry, when the clock changes in this process, so now we've got a synchronous reset. The previous one, remember this reset, if reset equals 1, was outside of the rising end. Now we've got to have it inside the rising end. So it's a synchronous reset. And if we do that, then we just set the current address to 0. Otherwise, we load the current address from the A register. Otherwise, we just take the current address and increment it by 1 and store it. Right? That's all the program counter does. And then I've done my usual trick here of having a temporary signal and wiring up the temporary signal to the output. So there's the program counter. Now let's have a look at the ALU. And again, I think the ALU is something let's see how far we got with the ALU. So I fully admit I'm cheating with a lot of this stuff, right? This is coming from Nanta Tetris, and there are lots of nice web pages and videos showing the solution for within the HDL that Nanta Tetris uses for this project. So these comments here are from one of those, and I should have put the URL that I took this from. We'll make a note to do that. And this is in the AL. Oh, that's right. So the ALU does different things depending on the control signals. And there's 1, 2, 3, 4, 5 control signals. ZX, NX, ZY, NY, and F are all control signals. Right? And depending on those control signals, it does something different. The ZX and ZY set the value of X and Y to 0. The NX and NY complement X and complement Y. And then the F is the actual function that the ALU does, and it's got 2. It's got an addition, and it's actually a bitwise AND, even though ampersand in VHDL is a concatenation. Right? The other thing it's got is you can complement the output. So there's an NO. Apparently, it looks like I left off the NO input. So I should. just leave a note for myself about that one. And if you go through some of the examples that are online, implementing that functionality is all done through the Mach 16 device. Right? Just about every single thing, the acting on the ZX and ZY inputs, acting on the NZ and NY input, acting on the F, is all done through those multiplexers. So for example, here's a ZX mux. So we've got the X input. So we've got on one side of the input we've got X, on the other we've got a 0. We've got a clock, we've got the ZX input, and we've got whatever the output is. So all this ZX input is doing, it's selecting between X and all zeros. Same with the ZY mux. It's selecting between Y and all zeros. The NX and NY is selecting between ZX, so the output of the ZX mux, and the bar of the output. You'll see down here the X output bar is just the not, bitwise not, and ZY is the not. So that's doing the first few things. And then we're always ANDing the output of those functions together. We're always adding the output of those functions together. And then we just put the AND result on one side and the plus result on the other. And we take our flag and we select one or the other. And the NG is saying whether the output is greater than 0 or not, and we're assuming 2's complement. So if we look at the high order bit, the sign bit, if the sign bit is 1, then we've got a negative number. So that's what that one's doing. The 0, 1 is, as you can see, a little bit excessive, but basically I'm just taking every bit of the output of the ALU and ORing them all together. I suspect there's a faster way to do that, but I just decided to make it, it's bit 15 or with bit 14 or with bit 13 all the way down to being all with bit 0. It's probably off the end of the screen. So that's the ALU. The difference between what that ALU is doing and the way you would program it if you were doing it in C or Java or JavaScript, whatever, is we're doing everything all the time. Right? If you were doing it in a procedural language, if one of those flags was 1, you'd do one thing, and if one of those flags was 0, you'd do the other thing. Because everything's happening at once, and we've got enough hardware to calculate everything all the time. The only thing that's coming out of the ALU is the thing we select based on the control bits. Right? What the function is, whether we're zeroing out one input or the other input, or whether we're complementing one input or the other input. Okay. So that is about all I have to talk about. What I would like to try and finish today is I want to try and spend some time connecting this all together. Whether it'll work or not is another question. What I want this group to do is to look at if you have been assigned a component, see if you can get a test bench working for it. Michael, I'd suggest not a test bench, but just finishing up and making sure that you can use that project to skip through all the valid numbers. Okay. And yeah, I think that would be good. Any questions? I'm okay if you pair up with any of that. So that would be good. Yeah, Eric, you and I might want to talk about the CPU. Okay, so let's do that and get that finished. Like I said, test bench or working with somebody on their test bench for your particular component. Now, what I want to do. Yeah, what's up, Michael?
Show you something?
Why don't we just do the work on it? Show up.
Now, the only thing is going to be that these last two, which they should be just 10, 11, 12. No, the number that we would get here is an intercept. And it's decimal, so it's going to be, it's still going to be a full bit number, but it's only going to be decimal, so it's going to be 2 or 3. No, this.
So I understand that, but what I'm saying, these numbers are explained. So the board has 4 digits, right? So I understand 1 through 9, you just stay on 8 digits. But for double digit numbers, would it require 2 digits on the board?
No. So what we want to do with these is when this is a 10, which is A, it's a decimal. You want to display A, obviously.
Yeah. So this is the same?
So that argument for the width, the output of the 2 integer, is just a number, a decimal number. And the decimal number that you want to display as A is 10.
So 10 will show up on
A will show.
So how does the board know that I'm trying to display it? Hey, if I'm just writing 10. That's where
So when you display, when this value is 10, this 2 integer is out of 10, it's going to come here and say, okay, this value, the one you said when 10, this is say 10, and then we'll go here and do that number to display
the board already knows that. So all I need to do is just change the letters to actual numbers. The byte here stays the same.
The byte stays the same, sure.
Just change it in the code.
You're just changing it in the code so that it's decimal in the code.
But on the board, it would still display as A.
This is what's being displayed. I haven't checked it, but this looks correct. Right. It's only, I don't think this will compile because it's going to.
Okay, on the quote. Now, one other thing. So for So I noticed that in the sentence. So these white sources are opposites. Like, for example, 8 on the board would be 1, 1, 1, 1, 1. But because it's active low, meaning it's okay. So let's change that. Then, do you want me to push it?
Yeah. What are you working on?
Push it to the end.
Yeah, it's okay. Just make my quick corrections and I'll push it to the end. Let's see you.
Another question.
Hold on, let me just finish what I'm doing. Yeah, what's up?
I never created a folder.
Sorry?
I never created a folder. I don't believe it.
Probably not. Okay.
Because I know, I think there's 2 classes ago that was talking about creating a folder.
Let's do
But
it.
I think you already did a folder.
Yeah, I probably did. It looks like you had time on this.
That's it. That sounds good.
Let me check.
Which means you could actually upload it to the board and
Exactly.
test it out.
Exactly.
Cool.
Looks like I have made some changes locally, so let me just okay, let's see if we can compile that. Let's go back to the other. Second to stop. So Eric, I've just pushed to the Discord channel a link that shows the edits and page 2. I want to open that. See if that
at all.
So let's just
Good.
check. Let's just check that I got it. Doing everything in the right place. Looks good. Let's see if it compiles.
Did it work? Did it work? Thank you.
Found out actually did everything that they for the presentation. So I mean, I texted one of them like a week ago and asked me how we gonna meet the meeting talk with the job. He said he's gonna get this signal so he can let me know. And the day before the presentation, like you guys told me to do the presentation I believe it was important. So I have to stay on all night. He said there was no right answer, it was just most of the time it's good
The whole group dropped. He was
Name it on the file.
if you really showed the solution, you know, I have almost like this.
So when this works, I'll be done with my component, right?
That is correct. Have you done the documentation? Okay, so that's the other piece that should be done.
Yeah, so it's just the title.
Right, so if you have a look, I
And
think
then
I put an
description.
example, there we go. Right, so that's the format that I'd like to be put in.
Okay.
7-segment display.phd, and then a brief description, what the inputs are, what the outputs are, and then a more detailed explanation of what it does, and if there are any limitations. There might not be any limitations.
Now, can you explain to me again the need for new branch? And not just for this class, but in general. When
So-
do we need to create a new branch?
So it depends. It's completely up to you. If I'm working on my own, I don't need branches. But as soon as you're working with somebody else, you're better off. Every time you do new work, you make a new branch. And you only do your work on that branch because it could be that if the other person is also working on the project, that you're going to change stuff that they're using. And you don't want that cross-cutting to stop them doing what they're doing. Or rather, you want to be able to coordinate with them at a known time, rather than just clobbering them until you wanted to. Right? That way, if you've got a separate branch, then you can say, okay, I'll merge it onto main, and if you get there first, and that breaks their code, okay, it's bad, and they may have to come and talk to you to figure it out, but it's up to them to fix
there's similarly you try to get the first paper field lead but it's better doing it that way than having it happening 5 times a day with everybody pushing to
Push.
know.
Makes sense,
What's up?
I just have a couple of questions on what am I supposed to do? Because I didn't get a personal email like from you.
I did.
Because the assignment says you're supposed to wait
Yeah.
for this one. And,
Okay.
I mean, I'll put the LEDs, so, and you already did the code for that.
Right. So
So this is the file that I need to do.
yeah, but rename it to whatever the name of the VHD file is. Yeah.
So just do that.
Yeah. Exactly.
Alright.
Yeah.
Just like what's the.
I mean,
what's going on?
if you already have an MD file, it's probably there. Just change it to this format.
Okay. And that should be it.
Yep. That'll be it.
Alright, thank you.
You're welcome.
And any other code or components is optional or?
I don't think so.
Okay.
Okay. So. Okay, that compiled. Let's generate that guy. Start it. And we failed. Why did we fail? What? Oh, because I turned it off. Let's turn it off. There we go. Let's do that again. This time with a faster clock rate. So what is it? 100,000. So does that help at all, or is that?
You have a whole course project file because I just took this and it didn't file with zero. These components aren't really related. I can't find the project file with. So, is there a project file over there? This is directly connected to what 9 is installed. Actually, I still need to one It's got already one box off. Two things I go for. Try to max out the RAM, try to get an SSD. Yeah, see that's what it does. Yeah, I mean, this bus is sort of one layer up. Not much to it, it's just substantiating the devices.
try that again. Okay, there we go. Okay, Michael, we have a problem.
Ready addition one.
So there's 3.
4. Okay.
Alright, so let's just reprogram it and start from 0 again so we know we're in a known state. Right, so there's 0. 1, 2, 3, 4. It's flipped. It's 5. It should be 5. 6. It's flipped.
Okay.
7. You've got one of the
Okay.
8. 8's okay. 9.
Flipped.
And I'd probably do the one down the bottom, but yeah, it's flipped.
And then 10.
10 is okay.
Solid, yeah. E.
That top one should be the bottom. Sorry, yeah, and it's flipped, and the top one should be the middle one. Right, then it'll be a small b.
C.
Again, it's flipped, and the top and bottom, the middle and the top are swapped, and it's flipped left to right.
Why did it flip?
Because of the ordering of the bits. Right? The ordering of the bits is G, F, E, D, C, B, A, not A, B, C, D. Right?
And that's
why
the software that comes with this.
That's correct.
Okay. So this is supposed to be in the E.
And the F is flipped.
It's funny. And that's funny.
It is. Okay, can you fix that or have a look at that?
Switching to.
Yeah, I know. I don't know.
I looked at it for other stuff.
So, what have I have a look
Yeah, I put a switch in the one that was right there. So I had 12 volts.
Okay.
trouble with this is when you do that, like it starts voice up in the seed folder program /006. So when you create a new project, it's going to save that project in the seed folder program /0. Right. So let's just close the program.
Okay, that would be.
So the F, for example, is supposed to be but it's the other way.
Delta back.
Exactly. So, because it's only because on the board it goes to C's down, not A. And then for some, I think the 6 was like regular 6. I'm not sure.
Okay, what was I doing? That one. be right back.
I wouldn't discuss it.
Yeah.
You already know. Like, look, working.
I think you will be too. It's just like, you know, I guess we get, like you said, you learn that to make
Essentially, I think
people, I mean, it's only like, it's not much, but you said like it helps explain how to implement the CPU. And like, you know, that's why shit does not do that.
did you write like started something for this?
I have a template pulled up. I don't know how to write. Do you feel comfortable writing a test bench?
Other mine does quite true.
No, just in general.
Well, I don't.
Yeah.
Luckily, mine doesn't.
You son of a bitch.
I already told him I want the easiest component. At first it was a little difficult, but since he started it, and basically all I have to do is add in the rest of the numbers.
Yeah. I gotta get you something that can perform like a whole Windows machine. So I'm gonna do that.
I've only been thinking in the past, but to really do this, I've done this shit in the past. Yeah, that's what I'm saying.
Like you can get your program counter to spin on that.
It's not even attached to anything else. It's just running as a separate code. See, the words are words. But to be able to integrate it, that's what I was saying, you know, with the wisdom.
Oh yeah. Well, I mean, he kind of did.
I just started. Push it. Remove.
Oh, yeah,
Professor, one question.
Uh-huh.
Do you expect anything to be completed tonight? And how far do you expect this to be? Not in terms of mom, but in terms of entire school.
I don't think I'm going to have mine.
And test benches?
Yeah, just test matches.
Your test benches. Do you expect test benches to be finished by the end of the class?
No. I mean, I don't think a test bench for yours is certainly useful. Yours is getting it to work on that computer.
And that's not integrated to it. It's just a separate piece of code that seems to be working on both.
That's correct. So separate. It's in the same result.
Oh yeah, but I'm saying it's not integrated with the other components.
No, but it just shows
It shows
that
that it
way
works.
they work. Because we got
That thing with the template
it's going to be customs. That's okay. We get the A instruction. What does the A instruction do? The A instruction loads value You could always do that. So we're going to test bench just for the CPU. Just tell.
You did drop it? Did you drop it? Okay. We were working on the last week together on a project, then it just stopped responding. I said, what's happening? He said, I dropped it. Literally 2 days ago. How would you? I don't know, but is it amazing came from two of us? Yeah, I don't understand how he's not what? So he's how is he gonna graduate? I mean, as a course. He's not graduating. He's already planning on graduating next semester. That's why I said, fuck. This has to be out to. He's finishing the class on the how the hell is he doesn't take the 201 either? It's 200 level course. He's not dropping it. Dropped it like 2 weeks before the final two. Dropped it last week. That class was like 13 or something. Yeah, final two. He said he missed a test of some sort, so he not none. But I guess it's all but he's passed it, but that's it. That's fine. I was so confused. I was like,
So I lost the box. My wife put it in the trash. She thought it was just an empty box.
Okay.
But I have everything else here.
Okay, so you got a bit? Cool.
Yeah.
That's okay. Thanks, Rod.
You're welcome. Yeah, I got a fancy box for me.
Very good. Cool. Thank you.
You're welcome.
So it just pushed. Hopefully, didn't break anything.
Okay. Sounds good. Let's Go back to the
That's a 501 class. That's a
7-segment display. See what happens.
Now within that push, I also modified my MD file.
Okay, so let's have a look
check
at that.
out as well.
Well, I have one more question. These three groups this semester last semester and this
So, Michael, with the, where's it going?
You got an issue?
So, yeah, so tell me how long it is. Right, it's a split of logic vector that how many bits is it? Should have the full 15 down to 0. Same with these two. So split of logic vector is just the generic type, doesn't tell you the number of bits. So
we have so much to do for like that just clicked and we can't keep all
You're a very fast reader. So
that looks good. Yeah, so just change those three versions.
I don't want to modify yet, especially if
Let's do this first. Yep, it's okay. Start again.
my boy just chilling, bro.
What's that? Oh, it's, yeah, that's, so this is the signal processing stack exchange. I'm a moderator on it, so sometimes I have to go in there and tidy stuff up. Let's pick that one back up. Let's see if that compiled. Open that. Got it turned on. Let's see if it's the right way around this time. Okay, so 1, 2, 3, 4, 5 looks good. 6, 7, 8, 9, A, B, C, D, E. Is that an E? Yes, it's an E. F. Looks good. Let's see if we can.
The solid.
It looks good. just take it up to 5. Too much clicking otherwise. There we go. Very good. Nice.
It's cool.
Yeah, so any thoughts?
I'm not gonna lie, I'm pretty lost on this.
So, yeah.
This is kind of an overwhelming component, honestly.
Yeah, it is. Right, so I think we can see in there, it's ludicrous to think in their API, and all they're doing is wiring stuff up into well, I'm not sure that's all we can do now. What we could try is forget about the fetch stuff and just make sure that the connection is right. So that was one thing I'm trying to ask myself, what would I miss this? And I think what I would do next is just try and run it but for the simulator. Okay, and see if that tells me so one thing I could look at in the simulator of the whole thing is just whether the program counter works. Right? If I provided I feed it the clock, the program counter should just tick up.
You can observe that through
You can
see like in the valley or does it show the graph?
So you run your there's the right. So I have down here I have a signal called program. And when I do my models, these show up, but any signals might also show up. Okay. So I can just look at that signal and see, is it there? And it doesn't change. That was what where I'm going. In fact, I probably tried to do too much. My initial thought was, let's try and make it a instruction. So I know now thinking was backwards as let's try something simple like is it doesn't program. So if you want to try and just get that maybe just try and do that.
So would I be doing I wouldn't just have to
Yeah. So what I'm trying to do processing to start. Oh, you've got it all there. Okay, so that's good. So the map is just saying this signal gets connected to the clock input and puts it on. It doesn't change the value, it's just wiring.
Okay, that's it.
Now I want to change the value, and that generally will be done either in the body of the architecture, not the function, or some process. That's the clock. Well, we want to make sure that the reset is not being used. We don't want that. So let's just set it.
Show the took 7 minutes.
And I also want to overlay
The only thing in that program is so you know on the functional requirements, yours and other set of numbers,
I don't think it makes any sense to have those two
acronym,
different.
that's
It does when we're putting it on the board. But it,
Yeah, because we're doing that.
that sheet's on.
so it's just
That's it. You realize
so we're deviating that there. So what I'm
that would be fine. I had no doubt.
just interested in the process.
We'll be able to reach 10 minutes on my section. Just spread them forward.
I'm just going to change that. So now,
But we got the break.
sorry,
Perhaps.
could be on the clock. Well, that you, it doesn't matter in the simulation, you're just going to choose one, make sure we know which one. So let's change it to the clock. Well, the clock is just going to go one to the other. And then if I allow for that, then that's trying to simulate it, to see if we can pull out the appropriate stuff.
Message, photos, is that the API that
Right,
you're
so
talking
now,
about? When you
So
server,
that's why like
server,
what's called Expo.
oh, no, if you got the board, what, where you can't electrical code.
I mean, my head,
Yeah, I think that's like
probably, I think I had to use Visual Studio myself. So much stuff. That's what makes that, makes that process way much easier.
Sure.
Oh, I also had to tell you.
Not the 13 was right.
That's still a effort too. It's all almost.
I imagine having to purchase a Mac laptop for that screen market.
Well, no, I wanted to just like personal use, so I said about maybe over the summer before we brought it up.
Before Larry switched on from Mac to Microsoft. You guys know why?
You want to know why?
So you good on PC already? You have a you're like stressed. I think it's one about it.
Oh my god.
I was like,
Oh, the second one.
right now,
Plus the solid state, so
What it shows on the radar?
NVMe is slightly faster.
Oh.
Maybe in the future, swapping over. But now it's too expensive.
Because you
I was turned on some money. Yeah, I was home too. So I was about to burn it through it. Now,
What, Intel?
There's a total of which one does
where AMD has crossed the threshold by like 50 there's a jeez. You broke your computer. No CPI. That's how they bring up tough and it goes like way down. That's where they show those CPUs are general.
what you do.
I know my Ryzen 5, if it's the 600 series, that's the 600 series, this is like i7, 9600 series. Ryzen 5 too, I'm not even using 7.
That was
Yeah, I just don't want to totally that's not CSS is not
That's a huge discrepancy. 14K, 22. But it's every academic year.
Would it be,
Now, if you had the I-9, matter of fact, if you're the I-9, same thing if you're the I-9 versus my senior. That's still very
for some reason it doesn't pop up. Don't say that.
I mean, I know what month, okay, month. We're talking about the beginning of March. About to graduate. You gotta wait till the beginning of March. Then, I don't even know if I should put on my resume, not graduate, or do I wait until March? I've been thinking about this GPA. I changed it. So I have a 3.3. I changed it to 3.6. Because I feel like they have software that scans your GPA. If it's not above a certain threshold, it disconnects it. And I don't feel like my GPA represents me. I could do the two, but
PhD, I walked in 92. Right. Between 92 and 2017, that many people asked me to volunteer. I went to work as an adjunct at Fairfield, and they insisted your diploma is not enough. I had no diploma. We want your transcript. I couldn't find my transcript because in Australia with a PhD, it's just research, so it says enrolled. Right? There's no GPA or anything like that. So I got in touch with a oh, just go to the website, order it electronically. Okay. If you graduated before 2001, it's not available. So I had to pay them to scan my paper results that they had so that it would come into their electronic system. And then I could.
They had your actual transcript.
They had my actual physical paper.
You're storing it somewhere.
But they just hadn't scanned it and put it into the
I think they pay for something a lot. It's like the warehouse, open a couple of doors.
So in 1992,
no. Yeah. Said my sister.
I feel like some companies,
Well, especially what we're applying for right now.
the software is not,
Rocket scientist, NASA. You're going for an entry level job. You're not going for an
I'm gonna just leave it there. They
entry
said, Greg, all you gotta do is want to support.
So what happens when they say, give me your transcript?
I gotta sit there, different job, different offer. It's me. Decided to, he just said no one asked about his kids. Since 1992.
Yeah, but you're the one worrying about your GPA, so I'm saying, what if someone
I'm
says-
just saying, no, well, this is new information, so.
You request for transcript, not brief. Putting brief for the son and it's
The crazy thing is, I have worked in places where I had to have a PhD, but they never asked for
Easily
it.
just put
I don't know. I think it's because it's
no idea what I'm doing.
Magna cum laude.
I think it's because it's a, what do you call it, an old boy thing, right? Because people are being hired by my PhD, right? So they didn't ask. And that's arguably easier and more correct to do the paper.
Where do you work on?
Try the same thing online and see what happens.
I think we can try to simulate the whole thing. We're just trying to get the program to output. If we're trying to get everything,
We were trying to get everything ready.
yeah, the computer starts scrolling.
It's a computer simulating a computer. What's your problem?
Yeah, but this is the hardware. Very technical. This is what I can make the software. Just trying to get the output.
I guess some code because at the start of asset management. So asset assets for the company, right? So company trust. So this computer is supposed to be assigned to some. I'm sure it's easier to go. It's assigned somewhere in the database. This computer name is computer number 3, blah blah blah, and has all of this. So in my company, asset management, it's the same, but it's cheap. So what I'm working on right now is I'm actually making a software. Super simple. I'm not actually PowerShell script that runs on the computer. Well, it's gonna pop up a dollar on that person's computer. But what is your name? So that's not like what is your cost? I can find out who's using it. I can go pretty much a script that runs on the computer. And it's asked them to give it cost center. Cost center is in business and it's like a banking company.
Where is that stored? After they submit?
They can make a ticket super easy.
Where is that stored?
So, like the software?
Or where does that ticket go?
It goes to China.
Like a database or to?
No, you make a ticket, it shows up in my computer. Maybe today I got this pop up on my computer. It says to provide this information. I go in that, I can send a message. I guess that's what they're referring to.
So you have a database on it?
Yes, we have a database. It's a German company. The database is in German. But they're switching over right now. They're switching over to service now. I have the service now.
Or the or what did you do?
Yeah, just
You applied.
I'm an intern still. I'm not like
When you're an intern.
I'm an intern. I'm doing a little more work than my full-time.
Is it pay good?
It's hourly right now. I don't know what it is on the board. I'm in the
What's the experience that you do?
the experience I'm getting is big on it. The thing is, I was working for make fashion financing. You heard about that? Make fashion financing. You heard about that? That part was going. There was a private company that printed art for what? I was in it, but I was in a different contract. That was ever since then, I've been busy. Gotta go over the side. Which side? Insurance side. I don't remember. So this was Robert's side.
We're just trying to see if the program cameras work. And it won't load every time we simulate it.
A broken model, see.
Yeah.
I'm just going to try it on my machine. Okay, we should finish up.
It's in there. It's there. It's working. It's working. Yeah. What's the Want what? My friend ordered like a 50 pack on Amazon and it was just in here. That was so Do you have Crocs? Yeah. I don't, dude, I literally don't have anything to do with Pokemon.
Hey Fahad, what's up? Let me just finish this and get it started because it'll take a while.
It's a little dirty, but it's all yours.
What do we want to do?
Yeah.
Settings.
Yeah. I need to get more right now.
Simulation.
Oh yeah. I was supposed to
Oh, test bench. Test benches.
Dude, they're so complicated.
TV.
People sleep on it until you wear them.
I don't like about it, when I drive, I can lift my foot up on the prop, the cross is on the gas pedal. It's like I'm trying to put my foot on the gas and the cross is still on the, come on. Just work normally. It's so annoying.
Looks like
So for a time I did not like cross drive.
You just could have figured it out.
Well, I wouldn't say that, but other factors.
Oh, okay.
Other factors.
Okay.
But it start in some
Yeah, yeah. There's some oh, I get that.
hopefully I get lucky.
Do you I recommend
Okay, what's up?
Well, I guess
It's a weird
Is it like one of those things where it's like after you do it, you kind of like have a whole perspective change?
Depends. Depends what your mindset is.
You gotta be like all gassed up when you do it, or?
My friend asked me
Yeah.
Just check.
And I was, and then like one of my friends, it was like right when sunset, like he was wearing beach almost. So you can see the sun. And my friend goes, don't stare at the sun too long, you'll burn your retinas. And I'm like, what? And then it just all went. I was like, oh,
Just hit you like a truck.
oh,
Or like, was it like, where is it like?
I mean, it wasn't how it went. In a real fight, it better fun, but it makes sense.
Yeah, so the way I've calculated those marks is I put a tag into the successful icon. So I had the word tag.
They're pretty
I had the word tag for this one. And that was one out of 100.
Oh, it's that bad. Yeah, that's pretty. Just try and get the large targets out.
My friend said she was
How long for that? Oh, wow. Yeah, but that's the guy you trust. You know, like if you're doing something new like that, that's the guy you trust. He listens to him. What's the one? Yeah, I haven't tried to try that. The way he was explaining it to me, like he said it was like a 5 minute. He said what he did is he
Participation.
was fine. And he took another one because I guess the second one is what really does it. And the second one,
Okay, that should be updated.
things just like started getting like all like literally like tied out and like
yeah, no, it's not like, no, yeah, but I was
I think I changed it to
Yeah, I'm just gonna send it to you. It's a screenshot. Maybe I'm gonna send it with
oh really?
It's a screenshot.
Oh, it's there. Maybe a couple of bits because it doesn't really fit on one scratch.
Okay, maybe this one I don't know if I'm gonna redo it.
I probably get changes in that one.
I haven't
After, yeah. Thank you.
But I don't want to Carson did
The opportunities are hard.
he said that like there was a sound that he just heard hearing, and it sounded like a train just getting closer and closer, and the sound kept getting louder and louder and louder and louder, and it got to a point where it just went like everything just kind of like exploded in his head, and he was just like in this thing. I don't know. And then he said he just blinked one time, and then he was back, and then he went to class. I wouldn't do that. That's pretty stuff.
You're loading
Yes,
this
yeah.
on.
It's all you need.
But I don't want to
Oh, yeah.
train.
I gotta take one.
Train like 2 hours.
Yeah. Did you sleep at night?
My boy was doing that. Wow.
I just haven't
They
been
were
hard
great.
to sleep.
New York, you.
Yeah, I was worried that I was going to go on.
Not living in It's too busy.
The minute I plugged in I got one of them. Was like,
Boston, I can see myself in Boston. It's not too bad. New York, what do you know? What's going
you know,
on?
like Boston. Why? What was wrong with Boston?
It's not bad. You're driving, there's like 10 roads that cross each other.
Yeah.
It's the last day, boys. That's knowing you realize. I might see you on TV.
Huh.
Won't forget you.
I spent 2 lives for class. I'm that guy.
Okay, so let's bring it back and let's finish this off. Okay? So I've been trying and failing with Eric on this machine over here to simulate the full thing. Whenever we try and load it up, for whatever reason, Model Sim just hangs. I have no explanation. This is arguably the most complex thing I've ever asked Model Sim to simulate. So it's probably a problem with that. So let me give you some feedback about what I think I've done wrong this semester. Right, these are my lessons learned. The first one is we've got to start the group project a lot earlier. Right? And I think it's a good idea. I think it's a really quite an interesting project. It's just we started it too late in order to get it actually done. So what I'm going to have to do is think about the earlier labs, maybe keep 1 or 2 of them, but start throwing in some of the components from the CPU into those earlier labs. So we get some of this project built before we start doing the full thing. I thought one of the things I changed this semester was to use that Zybook as the textbook. I haven't used a textbook in the past. I haven't found a decent textbook. And I thought that Zybook was better than anything I've seen before. I still think it is, but I don't think it's ideal.
Can we get a vote?
So there's no vote. I'm voting. This is an autocracy,
So-
and I'm getting rid of it.
By a show of hands, who thought the ZY books was helpful or useful?
Are we gonna count the grades or no?
Wow, that's a separate issue. So this is for next time, right? So I'm gonna one of the things I've done with CET 236 and Professor Broderick has it's not quite finished, probably won't ever be, but there's he has a textbook that he wrote, and I've helped him add a few bits and pieces to it. Right, and I'm probably going to do something similar for this, right? Write my own. It's not going to be complete, but it's going to be notes, and it's going to be a bit more coherent with what I teach. So that's my takeaway for that. The other thing is, I do like the idea of students using Git. I think it's something that you should learn as CET majors. You should know it. Even cybersecurity majors, you should know it, right? It's an industry standard at this stage. What I didn't do this time for this class is use GitHub Classroom. GitHub makes available a whole rake of functionality that lets me coordinate with you via repositories, individual repositories. What I did with you here was work with you through branches. But what Classroom lets me do is it lets me give each of you your own repository. It gives me a way to give you a starting repository, which you can then fork and work on your own copy. And the other thing that GitHub Classroom lets me do is it lets me run automated tests against your repository. And you can see the results of those tests. In fact, for the data structures course that I ran at Fairfield last semester, I ran all of their programming assignments had automated tests. And the students could always see the result of their automated tests. So they knew before the due date what their grade was going to be. And if their program passed 1 out of 10 tests, they were going to get 10%. If their program passed 10 out of 10 tests, they were going to get 100%. That simple. So I have to figure out how to do that with VHDL, but I think I'm going to go to GitHub Classroom next time. Please, if you haven't done it already, take some time now to get in and fill out a course evaluation. Okay? Say what you didn't like, say what you did like. I think I've said to this class and others, I tend to ignore all the numbers because they don't mean particularly much to me. I do read all of the free text, and if you've got complaints, please make them there. If you've got things you would like, please tell me there, and I might do more of them next time I talk. I think I shared with you my 2020 course evaluation, so you can see what people said last time. So, what do we got to do to wrap this up? Let's go here and here. Apart from the piece about maybe a test bench, I would need you to write a report about this group project. I want you to use your words, maybe some of my diagrams, but I want you to use your words to explain what the project was about. Obviously, we didn't finish it. One of the reasons we didn't finish it, I think I showed some people anyway. Is that the one? No. One of the reasons we didn't finish it is because I couldn't quite get my head around the CPU. And part of it is, let's make it a bit bigger, part of it is the Nanta Tetris HDL is a lot simpler than VHDL. So all they had to do for their CPU is wire it all up. Just like our top level entity, the pulling it all together. Right? And I don't think that's going to work for VHDL. And I just didn't, like I said, this week I was blown out of the water having to be in 2 different cities in 3 days, and I had to come home from New York City and then go back to New York City. So it was a bit of a pain. So I didn't get the chance to. I think all the other components are there or thereabouts. The ALU, the program counter, the MUX, the ROM, the RAM. I think they're all pretty much there. The way I would do this if I were actually building this in a real scenario is I wouldn't try to throw it together and then run the whole thing at once. I'd make sure that the program counter had a test bench and it passed it. I'd make sure that the ROM had a test bench and it passed everything. I'd make sure that the MUX had a test bench and it passed everything. Right? Remember, plan, do, repeat. And then when you start assembling it together, you probably wouldn't put the whole thing together. You'd maybe just look at putting some an integration, an intermediate test together. So, but that's on me. I left it too late to start. Is there something else? Go back to the slides. Right, so there's whatever the last draft submission was, if you haven't done that. There's also the project report. I want you to talk about in your own words. Have a look at the rubric to see what I'm looking for. Now I actually have 12 out of 12 students. Thank you. And if you have done anything of the HRD game, please take screenshots showing where you got to in the game, and that's again worth a bonus piece. Any questions? Matt? Let's leave it there. Thank you very much for an enjoyable semester. I'm expecting tomatoes or eggs or something. Now, let's take those out. See you later. I'll go. Oh, thank you.
Thank you, and I'll see you in the future.
Yep. I'll see you whenever the oral and that.
Yeah. Hopefully I don't miss that one for the midterm.
It should be okay. Just
Yeah.
make sure you have answers for most of the questions.
Yeah. I will try. Have a good one. Thank you very much.
Thanks for everything, Professor.
You're welcome. Appreciate it.
Now I have another one after Peter.
No,
I take care.
no.
When I see red, I'm not happy.
Yeah, I know.
Look, now
Red
it's only
is
the group project. I don't know. Maybe one is now.
Right, so that's the one that I
It's
have
not
marked.
great. Okay, maybe this one because you gave me 1 out of 100.
Yeah, so I said whenever anybody submitted something, or I forgot what I did, I put a 1 to indicate that I'd looked at it or I'd seen it.
it's not the green. The
Okay.
fact that it's not graded yet is, okay, so I haven't done any of those yet, okay?
Thank you so much, and we see you in Discord and the 10th, and we appreciated everything.
Okay, thanks for
Take care. Have a good day.
Yeah, you too.